Hi students, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. So everybody, this session is for all the students who are right now maybe in class 12. They have just jumped out of class 11th to class 12th, and those students who are droppers, right? Now, why this session is so important? Because in physical chemistry, right, in class 12 physical chemistry, we have concentration terms that you will see everywhere in the physical chemistry, right? Now, these concentration terms, especially in solution chapters, these are used, right? So that's why you should not only learn the formulas, good practice questions also you should do before starting class 12 physical chemistry. In class 12, you have three chapters, very simple chapters: electrochemistry, chemical kinetics, and solutions. Out of that, chemical kinetics is still on the easier side and not that much related to this, but electrochemistry solution is highly related to this. Even these concentration terms you will use in equilibrium as well. In some time in mole concept also it is applied, right? Because this concentration terms you have also learned in mole, like some basic concepts of chemistry class 11th, right? That time we learned it very non-seriously, but right now we will learn it with the help of formulas and with the help of good practice questions. We will learn how to decode these things. So everybody, are you all ready for this or not? Yes, very good evening students, very good evening students. So firstly, let me just introduce myself to all the new students here. Right, I am Diksha Kaushal students and I have done BSc, MSc in chemistry and also B.Ed, and I have 8+ years of experience, and I am here to teach you chemistry, to make chemistry fun for you, right? So it's, I believe in that every teacher, right, is if I talk about who is a good teacher, if you ask me, who is a good teacher? Who are lots of toppers in her class? No. A good teacher is that one who can make a backbencher a topper. A student who is not interested in studies, right? They become more interested. They start loving chemistry or whatever subject the teacher is teaching. And when you take out that student in the zone of toppers, that is a real achievement. And that's why I teach all the topics in detail so that every student out there who is facing difficulty, they can make this, it can get very easy for them. Right? Okay? Yes. So, shall we start? Ma'am, I can't concentrate on my studies. Then, just imagine one thing. Have you seen a rickshawala? Have you seen a rickshawala? Have you seen rickshawala? Right? Now, just imagine, is he not doing hard work? He is doing hard work, right? The laborers, they are also doing hard work, right? If you see any construction site, you will see a lot of laborers. They are also doing a lot of hard work, right? You will see someone who is earning maybe 5 to 10,000 in their job. They are also doing same amount of hard work. You will see someone who is earning lakhs and lakhs of rupees. They're also doing same amount of hard work. It's just that the knowledge, right? The one who is earning in lakhs, they have more knowledge, right? As compared to someone, even if I'm talking about any business, right? Anything, right? Singer, dancer, actor, the one who is earning, they have more knowledge. The hard work everyone is doing. It's totally in your hands. Right now, you want to chill and relax in life, and you, after 10 or 15 years, when you will have responsibilities of everyone, even your parents will be dependent on you. At that point, when you will be earning in pennies, and you will think about, I wish I could have done hard work at that point. Because right now, if you land up in a good college, directly in the, when you have a good college and a bad college, in a good college, more probability that you will learn more skills. In a bad college, you have to struggle a lot to learn new skills, right? In good college, you will have more opportunities and hence good placement, right? In bad college, it will be very hectic. Only 1%, or I would say 0.001% out of that bad college will get, good package. So the probability of getting good package, once you land up in a good company, promotions, everything are more probability. It is more on the probable side, right? That means your life, your dream life, it's in your hands. Either you can make it or you can kill it. It's totally your choice. If you think that, okay, I'm not focused on studies, you are ruining your future. It's totally your choice. You want to hustle more in the later life, right? Totally your choice. But then even if you hustle a lot, even then with those responsibilities, it is going to be very difficult. At this point, when you have no responsibility on you, right? At this point, when your parents are paying for your meals, for your fees, you just have to do is study. So why can't you even do that, right? At that time, when you will have responsibilities, you will not even have time to study. I have seen students, uh, right? They have financial problems in their houses. They have to earn money. They will study also, right? The passion for study is that much. Thanks to God that you are not one of them. Firstly, thank God and then start studying, right? Yes. Ma'am, I'm taking second drop. Please give me an. Yeah, droppers, I think I really need to do Q&A sessions for all the droppers out there. After this class, after this point, I'll start teaching because, otherwise, so I think I'll start answering your questions only because I know you have a lot of questions. Don't worry, I'll also take one Q&A session for you next week for all the problems that you're facing. We will talk, right? Don't worry. But to all the droppers, see, taking drop is not a bad thing, but I only advise drop to those students who actually are focusing or targeting something. If you are thinking that by taking a drop you can clear everything, no, it's not possible, right? By taking a drop, if you are ready to face society who is going to mock you every time, right? Those so-called relatives who are going to ask you every time, right? You have to ignore them, right? And if you have the capability of still focus on your studies only, right? Not to get demotivated, that is very normal, but you will not let that demotivation in between your dream, right? If you have that much capability, right, to do hard work, if you have a proper strategy, you have a plan, then obviously you can take a drop, but make it worth it. You can't just take a drop and lose one more year of your life, right? 1 year is very important, right? So don't do that unless until you are very sure, but the decision will be yours only. I can't decide for you, right? Neither your parents can decide for you, only you can decide for yourself whether you are capable of that. Are you ready to do that much hard work, right? Okay, so everybody, let us start the session without wasting any time. Okay, so now everybody fill this chat box with green hearts to let me know that yes ma'am, I am ready for the session. Yes, everybody, fill this class, fill this chat box with green hearts, right? To let me know that you're completely awake and ready for this session, which is going to be very important for your physical chemistry, right? It is the base of physical chemistry. Yes, everybody? Yes. Okay. Now, let us see. First concentration term that we are talking about is mass percentage, right? Mass percentage is number of parts by mass of solution per 100 parts by mass of solution. Now, Bacha, I'll give you a simple solution of this. Whenever you are talking about the percentages, right? Whenever we are talking about percentages, okay, I'll just write percentage here. Whenever we are talking about percentage, we will have three, or you can even have more kind of percentage. You can have mass by mass percentage. You can have mass by volume percentage. You can have volume by mass percentage, volume by mass percentage. You can have volume by volume percentage. These are the four kind of percentages that you can have, right? Now, percentage. Percentage is always in mathematics, you must have learned percent means we will multiply. We are talking about 100. We are thinking out of 100, right? Out of 100, how many bananas are good? How many bananas are bad? Out of 100, how many chocolates you have? White chocolate. How many chocolates are dark chocolate? Okay. So out of 100, we are talking about. So we'll multiply everything with 100. This will be multiplied by 100. This will be multiplied by 100. This will be multiplied by 100 and this also will be multiplied by 100. Now, whenever I talk about percentage, right, In this case, you take solute by solution. Solute by solution. And in this case, always take solute, right, in grams. Take solute in grams. Not solute, I would say take mass in grams. You can also write it here. You should always take mass in grams, right? And take, I'll just write it like this, take mass in grams and take volume in milliliters. Okay. Always take, because units also plays a very important role, right? Now, how do you write the formula? This is W by W. So that will be mass of solute, or you can also mention it by W, weight of solute. In chemistry, mass and weight are same thing, right? Divided by weight of solution or mass of solution. In chemistry, we don't get into weight is equals to a mass into G, right? In chemistry, we are talking about atomic level. That's why we take mass and weight as same thing only, right? So this is mass or weight of solute. This is divided by volume of solution. Okay. Then here it is volume of solute, right, divided by weight of solution. Last one is volume of solute divided by volume of solution. So this is what you have here. That means what you have to do, do you have to learn anything here? No. Just remember, in percentage, you always have solute by solution and it is always multiplied by 100. Now, whatever you have, weight by weight, weight by volume, volume by volume by weight, volume by volume, whatever you have, you can take it according to that, right? Okay. Now, we will understand the decode, right? Now, this is clear to you, but now we will understand what do you mean by 20% of sugar solution in water. That means how do you decode these things, okay? Now, we will understand how do you decode these things. Decode percentage given to you. Decode percentage given to you. Let's take an example that is given to you here. That is 20% weight by weight, right? Now, why I am asking you to decode this thing, right? Because in the questions of solution chapter that you will study solution chapter, okay? In the questions of solution chapter and also in some general questions of physical chemistry also related to mole concept as well, or they can put the same concept in any question of physical chemistry and make a new question for you, right? So you really need to understand how to decode this, because this one line is telling you a lot of things, right? This one line is 20% of weight by weight, okay? So this one line is 20% of weight by weight, right? Now, we know that weight by weight, we are talking about solute and we are talking about solution, right? So, always take, whenever percentage is given to you, we are talking about out of 100, right? In this case, we will take always in the denominator what you have the solution, you will assume the mass or whatever is given to you. Now, in this weight by weight, so we will assume this thing, right? We will assume this thing, right? So what you have to assume that weight of, or you can also write mass of solution is 100 grams. That's why I told you that you should know that what are the units you are using. You can't take it as 100 kilograms, right? You can only take it as 100 grams. Okay, otherwise you will eventually going to get confused again and again. Okay, so let's fix this to grams. Okay, so mass of solution is gram. Out of this, 20% is your solute, right? That means you will see mass of solute is 100 minus solute. No, mass of solute is given to you only, right? Mass of solute is 20 grams. Okay. Now, let's write the mass of the solvent. Anyone who doesn't know what is solute, what is solvent? Anyone who has no idea about what is solute, what is solvent? Anyone of you? Anyone? Those who have no idea, ma'am, what is this, ma'am, solute, solvent, then simple thing is we are having a glass. Okay, we are having a glass. The glass is not so fancy. Let's make a fancy glass, right? We are having a glass in which you have added water. Okay, in which you have added water, right? You have filled it like up to the brim, right? You have added water. Now you are thinking that 1 tablespoon of sugar I am going to add. Okay, now you are adding 1 tablespoon of sugar. Now the one which is in less quantity, right? I am not telling you that the solid is always solute, liquid is always solute. No, the one which is in less quantity, the one which is in less quantity is the solute. In this case, we are adding solid in less quantity, so the solute is solid, right? The one which is in more quantity, what is that, students? The one which is in more quantity, that is called, everybody in the chat box, that is called solvent. Now, when you add solute and solvent, we have solution, right? So, when you add solute and you add solvent, you have solution. You have solution. Okay, that's why solute we knew that it was given to be 20. This was given to be 100. So that's how we calculated solvent by 100 minus 20, that is 80. Right? Is that clear to everybody? Now, beta, always remember, right? This is one denotation that I am doing here, right? So how to denote, right? 2 or 1 we will use, right? Most of the books, even in NCRT, they are using the same thing, right? So let's fix this thing in your head so that you again and again, you don't have to write mass of solute, mass of solvent, mass of solution. You don't have to write it again and again. For solute, you will just directly write 2. For solvent, we will write 1. And for solution, we will simply write solution only, because in very rare cases, you will have solution. Okay? So this is whenever I write W2. Can you tell me this W2 is what? Students, what is this W2? What is this W2? This is mass of solute. If I write W1, that is mass of solvent. Now this may vary in different books, but to us it will be fixed. And in most of the books you will see the same thing, right? Okay. Clear, everybody? Now shall I start with the next thing? Yes, solute, mass of solute, right? Now, is this thing clear to everybody? When 20% of weight by weight was given to you, how to decode this thing? You have to assume the solution. Mass of solution, you can assume it as 100 gram, and out of it 20% means mass of solute will be 20. Mass of solvent you can easily take out of it. Now, volume percentage. Volume means volume of solute in milliliters, in ml, right? Present in every 100 milliliter of the solution. That means volume of solute divided by volume of solution multiplied by 100. Here they are talking about volume by volume percentage. That I told you the formula here only. I gave you the formula here only. Volume of solute by volume of solution into 100. Now, let's decode this thing. Okay, so I'll give you one example here as well. Let's decode that thing, right? Let's decode it. Yes, let's decode it. So, I'm giving you, again, decode. You have to decode this, everybody. You have to decode this. Now, if let's say I'm giving you that you have 40% of ethanol in, or you can just write solute, right? 40% of solute in volume by volume percentage. Okay, volume by volume percentage is given to you. Now, what all things you can decode out of this, right? 40%. We know that volume by volume means volume of solute divided by volume of solution multiplied by 100. Now, I told you the denominator one you will take it as, that means this one you will take it as the 100, right? Because in percentage they have given you, so you will take this as 100. Now, this you will have to assume, right? So I told you that volume will always be in milliliters and mass will be in grams in the percentage, right? So what I assume here, what I will assume here, that what you have here is, you can just write volume of solute is going to be 100 milliliters, right? Volume, solution. Volume of solution is going to be 100 milliliters. Volume of solute is going to be 40%, means 40 milliliters. Okay, so you can just write here 40 milliliters. Now, volume of solvent, you can easily subtract here 100 minus 40. That is going to be 60 milliliters. Okay, now we are just decoding these things. They will be used in other formulas, right? Okay, we will see that as well. So that is your volume by volume percentage, right? Decode clear to everybody how we are going to decode volume by volume percentage. Now we are going to see if mass by volume percentage is given to you. Mass by volume percentage, as I already told you, mass by volume percentage, that means mass of solute divided by volume of solution multiplied by 100, or definition you can write it as, using the pharmaceutical industry, it is defined as mass of solute dissolved per 100 milliliter of the solution, right? Now that is the formula that is given to you. Now we will try to decode this thing, right? Let's decode. In most, this also, now they will give you this kind of situation, right? Now you have to decode. Let us see who will decode. Now this you have to do yourself, right? Let's say they have given you, let's see who is going to decode this here, right? You have to decode this. This is given to you to be 30% of solute in weight by volume percentage, right? 30% of solute, or they can also write in bracket weight by volume, right? Now you have to decode. Tell me what you will answer me. What is the mass of solute, solvent, volume of solute, volume of solvent, and solution, everything. What you can tell me about this particular thing that I have written here. Anybody in the chat box? Anybody? Let us see who is going to tell me that. 30 gram of solute in 100 milliliter of solvent. Very good, Suga. Very good. So that means, can I assume that volume, I can assume, volume I will assume, and what I will assume? I will assume that volume is given to be you. You will assume it as volume of solution is equals to 100 milliliters. Mass of solute is given to be 30 grams. Now they are saying that, now can I just write down the mass of solution is 100 grams? Can I write here mass of solution is equals to 100 grams? Is it right or is it wrong? Tell me, students, can I write here mass, is it is correct or wrong? Let us see. I'll just give you the polls here. Let us see who is going to tell me that, right? Yes or no? Let us see that, yes or no. Is it correct or not? Is it correct or not? Right? No issues, Pratyush. Okay. Actually, okay. Yes. Yes or no? Yes or no? So, what I can see, 100% of you have written yes. That is actually not correct. Right? That is actually not correct. We can't write it like this. See, they haven't mentioned anything about the weight of solvent, weight of solution. They have not mentioned anything about mass of solution. It is between weight and volume. Volume is 100 milliliter In that you have 30 gram, right? Volume is 100 milliliter. In that you have 30 gram. We can't say that unless and until something is, some hint is given in the question. We can't directly assume that mass of the solution is 100 gram. That assumption will not be valid here. What is given here, we can only assume about that thing. This is in volume. We will say volume of solution is 100 milliliters. Weight out of this will be 30. So that's why 30 divided by 100 multiplied by 100 is giving you 30% here, right? So you can't assume that weight of mass of the solution is also 100 gram. That is a wrong assumption here. Okay? Yes, everybody. Yes, everybody. Clear? Done? Done? Now, yeah, I don't know. I've like so many times I have talked about this thing. Na? How can you guys be so innocent? I don't know. I seriously, I don't know why you think that when teacher is teaching you, I know, right? You when you know someone, see, let's suppose that you're in the class and you are talking and the teacher is like, telling you something, you are in that fun zone, and that's why you're like, okay, today I don't want to study. You have to sit in the class because of some pressure, because of attendance, and you're talking to your friend like this. That I totally understand. But I don't understand that what pressure I am giving you to sit in the class. And what is that friend? You don't even have their WhatsApp number, you don't have their Instagram ID, that you're telling them over call that, okay, come on this live and we will chat. Right? That means that you have told them every time Diksha ma'am is going to come live, we will chat here. That means you have no idea what person you are talking to, and still you are wasting very important time of your life with that person. I don't understand your mindset. Yeah, what mindset is that? Like, I think you're very rich, right? You have some tons of money or some villas or something, right? Somewhere you have some gold mine or something. That's why you're not worried about your future. Otherwise, I don't understand that how come in this challenging world where everyone is so competitive, right? Everyone is working so hard. How can you take your future so lightly? Right? You really think so? See, if you have some good business going on, your father is very rich, right? You have some factories or something, then that's totally fine. Do whatever you want to do. You have enough money, right? You don't need to do anything. It's totally your choice, right? Otherwise, I have seen people who have money, they are, into like making more money, right? They are more knowledgeable. But still, it's totally your choice. At least you will not be starving in your life. But those students who are from a middle class families, right? I don't know how you get this mindset that you can waste your time like this. At least if you want to waste your time, go and watch some movie with your friend, right? You want to waste your time, go and like, you can just play cricket or watch TV, anything you can do. Right? Wasting time over chat with a stranger, like I think psycho or what, I don't know what you're thinking. Like, what will happen after chatting with a stranger? I don't understand your psychology, yeah. I seriously don't understand that. Okay. So all the best. Those who are like very, very rich, who think that they can waste their time, all the best, yeah. All the best for you, right? Give also us some money, right? Fund us, right? So that we can also know what richness you have, that you are like, okay, ma'am, paisa hai, ma'am. Too much money, ma'am, we have. We don't need to worry. Wasting time with stranger is cool, ma'am. Huh? Chal. Bitter, please don't spam. Right? Okay, bitter, don't worry. Yes, we will start. Don't worry about that. Right? Okay, don't worry. Yes. You told reality, ma'am. Yes, that is the reality. You don't even know which person you're talking to. You have no idea what is that person. Is this a person or a robot you are talking to? You're still talking to. Oh my God. You're like, oh my God, she's coming live. I have to, go in Diksha ma'am's class and I have to chat with that girl or boy, whatever you're talking to. Right? Are you that innocent? If you're that innocent now, then I really pity you. Because I don't know why no one is guiding you for this, right? Then it's very scary that if you're that innocent. This whole world will kill you, right? Otherwise, I don't think so. You are that innocent. You just like wasting your time. Reality will hit in like 1 or 2 years. Just wait for 1 or 2 years. Reality will hit. When all your friends who are working hard right now, right, after some time, they will be placed somewhere and you will be jobless at that time. Your parents will get, will be in that situation where they want to get retired. They are tired of working for 20, 30 years, right? Doing every sacrifice for you. And when it's your time to do for them, when you will have nothing to do for them, then you will realize that what mistake you have done. What mistake, right? So be aware of that thing. If you're from a middle class family, these things will shoot up and then you will be totally blank, and all these friends out there, they will not help you, right? They are not Bill Gates that they will give you job in their company, right? So be aware what future holds, right? Otherwise, just pray that something hits and universe dies. Only that can save you. Otherwise, competition is very high. Even the skilled persons are not getting jobs. So just think very, very carefully, right? Okay, now let's concentrate on our studies. Mass percentage, weight percentage, volume percentage, everything we have learned. Now, next concept is mole fraction, right? Mole fraction. Mole fraction is, it is the ratio of number of moles of one component to the total number of moles of all the component present in the solution, right? That means you have a beaker. Let's say you have one component that I'm mentioning by pink color, right? You have next component that I'm mentioning by blue, right? Let's say you have the third component that I'm mentioning by, let's say, white. Okay, this is the third component, right? Let's say you have the fourth component, I'm mentioning it by green, right? Now, it's like you have in a glass, you have glass of water, you add sugar, you add salt, you add lemon, right? You add some, uh, spices into it, right? You have your lemon soda ready. You add some soda into it. You have like lemon soda ready. So all these are the components of that mixture, right? In that component of mixture, if let's say I want to know that what is the mole fraction of sugar, then what I will say, mole fraction of sugar is number of moles of sugar divided by total moles of sugar, salt, spices, soda, water, everything. That will be total number of moles, and this is highly elite. We will use this so many times, right? So that is the mole fraction, right? So mole fraction is you have, let's say, n number of components. You have, let's say, let's say m number of components you have. Mole fraction of third component you want to know. So that will be number of moles of 3 divided by total number of moles of 1, 2, 3, 4 up to m, right? The total components that you have in that mixture, the moles of total components, that is called the mole fraction. Okay, so you can write it here. Let's say you have two components, because in your studies we will only discuss about, in solution chapter we will discuss about binary solutions. Binary solutions are in which total amount of solute plus solvent is 2, and always in one solution there can only be one solvent, right? Solvent maximum quantity will be only of one thing, right? That is, there can only be one solvent in a solution, right? Now, when you have one solvent and one one solute and one solvent, that is called binary mixture, right? And in a binary mixture, let's say you want to know the mole fraction of A, then mole fraction A is number of moles of A divided by total number of moles. Mole fraction of B is number of moles of B divided by total number of moles. And very interesting part is mole fraction of all the components in the solution. If you have m number of components, then mole fraction of 1 plus mole fraction of 2 plus mole fraction of 3, so on up to mole fraction of m is going to be unity. If you have 3 components, mole fraction of those 3 components is unity. If you have 10 components, mole fraction of those 10 components is unity. So that means mole fraction of all the components that you have in that mixture is going to be unity. This is a very, very important point that you will use in your 12th class, right? Now, let us do a JEE main previous year question based on the mole fraction. First is a 5.2 molar, right? What they have written here. Okay, wait a minute. I think you need to wait for this thing here. Why? Because right now we have not done molarity, this we have not done. So I will not come to this part, right? Molarity, firstly we have to study. Okay? Firstly, this is molarity. Wait a minute, let me see if there is a separate. Okay? So I would want you to study firstly molality, then molarity, then we will discuss the questions, right? So first here it is molality, okay, not ritty. Molality, molality. Molality is denoted by small m, right? Why I am saying again and again? Because there is 2 formulas, that is molarity and molality, that you will use like so many times in physical chemistry, right? So molality is number of moles of solute divided by, or you can say present in 1 kilogram of solvent, or from the formula you can say that it is number of moles of solute divided by weight of solvent in kilograms. Do you remember in percentage formula, I specially mentioned that the mass will be in grams, the volume will be in milliliters. So that's why here special stress I am giving on that here weight of solvent will be there and that will be in the kilograms, right? That will be in kilograms. So that means we are discussing number of moles. Let's say you have, this is 1 kilogram of solvent. In that, how many moles of solute you will add to make that solution? That is called the molality, right? So we know that number of moles are given mass by total mass, given mass by molar mass. That will be given mass by molecular mass multiplied by weight of solvent in kilograms. That is the formula of molality. Now, can you tell me what is the formula of molarity? Anybody? What is the formula of molarity? What is the formula of molarity? How you can remember, right? Who is a big fan of cricket matches? Who is a big fan of cricket matches, right? You must have heard about Virat Kohli, right? So what you can understand from here, V is volume, right? R is molarity. It's R, difference is R, no? In molality, it is L. In molarity, it is R. So this is molarity. Okay, this is defining the molarity. Now, this you can remember because usually students get confused at which was volume 1, which was weight 1. In this case, it is same as molality. It's just that in position of weight of solvent, you will write volume of solution and that too will be in the liters, not in milliliters. So you will write molarity is number of moles of solute divided by volume of solution in liters, and we know that number of moles of solute is given mass by molecular mass. So that is given mass by molecular mass, volume of solution in liters. If I write this in very, very important, if I write this in liters, you don't need to multiply it by 1000. But if I write this in milliliters, I'll have to multiply this by 1000, right? Same is the case with molality, right? If you want to write molality here, you can also write in the same way. That is molality is equals to given mass. You can given mass of solute we are talking about. So W2 by M2 molar mass of solute multiplied by weight of solvent. Solvent is denoted by 1. So it was W1. Now, if you are giving this in grams, this will be multiplied by 1000. Okay, that is the formula of molality, right? That is the formula of molality. Now, The formula of molarity, you can also write it again here, right, in simple words. Molality, or you can say molarity, is given mass W2, given mass of solute, by molar mass of solute multiplied by volume of solution. If this is in liters, then if this is in milliliters, this will be multiplied by 1000 here. These are two very, very important formulas of concentration terms. Very important formula. Right? Now, is that clear to everybody? Very important formulas. Molality, molarity. Now we will solve this question here that is given to you. 5.2 molal aqueous solution. Molal aqueous solution of methyl alcohol. That means molality. Molality is given to be 5.2. Okay. Methyl alcohol is the solute here, is supplied. Okay. Aqueous solution means solvent is water. Can I write solvent is water? Right? Solvent is water. Do you know what is a molar mass of solvent? We know that molar mass of solvent is 18. So we right now know the molar mass of solvent. Right? What is the mole fraction of methyl alcohol in the solution? Okay. So they are asking you the mole fraction of 2. That will be number of moles of solute plus number of moles of 1 plus 2. That is number of moles of solute plus solvent. Right? So is there any direct method? Right? If they have given you 5.2 molar, so can I just assume that 5.2 molar, can I decode this? Can I write this as 5.2 moles of solute in 1 kilogram of solvent? Can I write this 5.2? Are you able to understand this thing? What is molality? Molality is number of moles of solute divided by weight of solvent in kilograms. If they are saying that this is 5.2, so I can also take this as 5.2 by putting this as 1. So can I say if molality is 5.2, that means number of moles of solute is 5.2, then it is there in 1 kilogram of solvent, right? Can you decode this? Perfect. Now we will just answer it on the next page, right? Once you know this, I think everything else is sorted. That means you right now know what is N2. N1, can you calculate here? N1 is what? Can you tell me what is N1? What is N1, students? What is N1? I'll just calculate. Where should I calculate? Okay, I'll just erase this thing. Should I? Okay, I'll just erase this thing. Right, N1 will be equals to weight of solvent by molar mass of solvent. Weight of solvent is 1 kilogram, that is 1000, divided by 18 is the molar mass of solvent, right? You just need to put it there. N1 you know, N2, this means they are talking about N2 here. N2 is this. N1 you know, N2 you know, you just put this formula here and you will definitely get your answer. Now students, what I have to put here, molar mass of the solute they are asking you, right? This is N2. N2 is 5.2, right? You just put 5.2 divided by 1000. This is 18 plus 5.2 and you just need to solve it and you will get your answer. Is that clear? Okay. Is that clear? You just need to solve it and you will get your answer for mole fraction of the solute. Is there any problem on this question? This is your JEE previous year question, right? Okay. So that is just based on the concentration terms. You can easily answer this, right? Okay, students, you can easily answer this thing here, right? Okay, this is the lengthy method that I have not taken, right? Okay, answer will come out to be B is the correct answer. Okay, perfect. Now let us see the next one. That is, let us see the next one. Next question. Let us see. Okay. Now this is the relationship, right? This is the relationship between some important concentration terms, right? Out of this one, this is molality and weight by weight percentage. This is molarity and weight by volume percentage. If you want to like cram this, you can cram this. Otherwise, you know, by decoding also you can answer this. By decoding also, if you don't want to cram this, you can also skip this. But to make the calculations and the speed fast in the exam, you can definitely cram this as well. You have time, right? So this is by definitions only we got that formula. Now, next is, if they have written in the concentration, for example, they have written semimolar, decimolar, centimolar, millimolar, right? So millimolar means they are talking about 0.001, right? That means they are talking about 10 raised per minus 3 molarity. Decimolar means 10 raised per minus 1 molarity. Semimolar means 1 by 2 molarity. Centimolar is 10 raised per minus 2 molarity. These simple terms are very important for you to remember when you're solving the questions, right? In the question, what if they give you, it is a centimolar solution. Centimolar means they are talking about the molarity is 0.02. They can also give you it as a centimolal solution. That means molality is 0.01. If they give you it is a decimolar solution, that means it is 0.01. If they give you molality, we are talking about, if they give you molality is millimolar, so you can write it as 0.001. If they give you semimolar, that means it is 0.5 molar. Okay, that's how you can understand these terms, and you can put this in the values that are given to you in the equation, right? Okay, let's calculate this next question here. Calculate the mass of NaCl required to produce 100 milliliter of semi-molar solution. Now, everybody, let's answer this solution question here. That is, calculate the mass of NaCl. So tell me, to produce this much of semi-molar solution, that means to produce 100 milliliter of semi-molar solution, can I write the molarity here? Molarity is given to be 0.5 molar, right? Molarity is given to be 0.5 molar. Now they are saying molarity is 0.5 molar. You have to calculate the mass of NaCl. Okay. Can I also write it as, can I decode this? Can I decode this? Can I decode this? That we know that molarity is equals to number of moles of solute divided by volume of solution in liters, right? If this is given to be 0.5, can I take this as 0.5 and put this as 1 liter? Is it possible? If I put 1 liter solution, molarity is given to be 0.5, can I then say that that means in, can I just write this thing here by decode? Decode is very important, right? Decode is very important. Decode is molarity is given to you 0.5. This is the formula, right? This is given to you in the question. This you are assuming. This you are assuming. I'll just write this you are assuming. This you are assuming. Whenever you are decoding, assume the denominator as 1. Right? So if I assume this as 1, this will be same as the answer of this formula. This is 0.5. That means number of moles. That means you can write this as number of moles of solute, or you can also write it like this. You can also write 0.5 moles of NaCl. NaCl is the solute. NaCl is the solute, right? So you can write 0.5 moles of NaCl in 1 liter of solution, right? So 0.5 moles you have. Now, those who remember, number of moles is equals to given mass, right, by molar mass. So you can write given mass is equals to number of moles multiplied by the molar mass. So can I write this simply here, that given mass is number of moles is 0.5, right, and molar mass 23 plus this. 23 is mass of sodium. This is 35.5. That is 5, 5, 6, 7, 8, 3, 4, 5, 58.5. Okay. So you can just write it here, right? 58.5 divided by 2. That will be the answer. Is that clear to everybody or not? If you're able to do these kind of questions, no one can beat you in concentration terms, right? because decode is important for you, right? Why I have asked you to learn through decode? Because see, directly also you can remember, right? From these kind of relations also you can cram, but I would not advise you for that. I always suggest my students that less formula cramming and more understanding you should know, right? So this is purely understanding based question, right? Is that clear to everybody or not? Students, a bit of PDF will be provided to you, right, on the Telegram channel. You can also, like on my Telegram channel or on the Vedantu J English Telegram channel, you will get the PDF, right? Even in the description box, you will get the PDF, right? Okay, yes. Now that you can do and you can just get your answer here, right? Wait a minute. Acha, wait a minute. Arey, I answered it wrong. So I'll just copy this. I answered it wrong. I'll just copy this. I'll tell you why. I forgot to see one thing here. One thing here. That was 100 milliliter. What if the 100 liter to produce? What if this was not given? Then you would have solved it like this, right? Wait a minute, students. If the volume is not given, then you can solve it like this. But now the volume was given to us, right? Now we will solve if the volume is given, right? So this becomes wrong because I have to solve it like even, complicated question for you right now, right? Because if volume is not given, then how to solve it, that I have told you, right? Now we will see if volume is given, then what we have to do. If volume is given, then it is very simple, direct formula based question it is, right? We know that molarity is equals to number of moles, that is weight of solute divided by molar mass of solute multiplied by volume, that is given in liters, right? Right, so this, if this is given in milliliters, this will be multiplied by 1000 here, right? Semi-molar means this is 0.5. Weight will be equals to, we don't know, we have to calculate. Molar mass is 58.5. Volume is given 100, this is given 1000, so you can easily calculate the value of weight here, that will be in grams, okay? So if direct volume is also given to you, then the question is very direct. I also told you when volume was not given to you, then what you have to? Then you have to decode and then you can answer. Right? Okay. Yes, everybody. Shall I move to the next question here? Right? Next question is, calculate the concentration of Na positive and Cl negative when 200 milliliters of 0.1 NaCl is mixed with 300 milliliters of this. Now for this you need to know what is dilution, right? Okay. So firstly we will understand what is dilution here, right? So firstly I say you can understand, calculate the concentration of Na positive and Cl negative when 200 milliliter of 0.1 NaCl is mixed with 300 milliliter of this. Concentration of Na and Cl you have to calculate. Okay. So that means in the solution we know that Na will Cl, Na will also dissociate, CaCl2, this will also dissociate, this will be Ca2 positive, this is 2Cl, right? One NaCl is giving you 1 Cl, one CaCl2 is giving you 2 Cl. Now, with these reactions also you have to take care, right? They are asking you the concentrations here. When you are mixing these two, let's see how we are going to solve it. This is a very, very interesting question, right? Because here you need to know 2-3 things, right? One thing is, we know that, I'll just, okay? One thing is you have NaCl, you have Na positive and Cl negative. Other is you have CaCl2, Cl2 positive and 2 Cl negative. Now, if you see this, firstly you should know that converted into moles, right? Now this is 0.1 molar, this is 200 milliliters, right? Now here, can you tell me that if molarity is equals to number of moles of solute by volume, if volume is in milliliters and you are not multiplying it by hundreds, that means number of moles also you have to put in millimoles. Then these two will cancel each other. When you're not multiplying it by 100, then I am talking about. So when volume is given in milliliters, you can calculate the moles in millimoles, right? That means number of moles will be equals to, you can just directly write here, number of moles will be equals to molarity multiplied by volume in milliliters, and this you will get in millimoles, right? So 200 number of moles of NaCl initially, that will be 0.1 into 200, that is going to be 20 millimoles, right? In this case, you will have number of moles of CaCl2, that is equals to 0.1 into 300, that is 30 millimoles. Okay, so now you have 2 millimoles here, right? One is millimoles of NaCl, millimoles of this. Now from the reaction we will answer this. Let's see how we will answer this. Initially it is 20, this, because we know that salt is a very good electrolyte. Okay, this is some basics of chemistry, that the salts are very strong electrolytes. Strong electrolytes means even if nothing is given to you in the question, even then you will take. Now salts are very good, even especially strong acid and strong bases salts are very good acid, are very good strong electrolytes. They will completely dissociate. So that means this 20 mole full will be dissociated into Na and Cl, right? This CaCl2, you have what here? Wait a minute. This is 300 multiplied by this CaCl2, no? It will be 30. It will be not 50. Okay, it will be 30 here. Okay, it will be 30. Some typing mistake must be there. 30. Okay, so this is 30, right? Full 30 will be dissociated into 30 Ca2 positive, and because see, simple thing is 1 CaCl2 is giving you 1 Ca2 positive and 2 Cl negative. That means if this is 30, this will be 30 and this will be 30 multiplied by 2, that is 60. That's why we have written it here 60. Now you have millimoles in all of them. Now bacha, you have to, they are asking you Na positive and Cl negative. Now you will only focus on Na positive and Cl negative. This is 20 here and this is 60 here and this is 60 here, right? Okay, common ion you have here, no? One is Cl, one Cl is from Na, one Cl from CaCl2, right? Now moles they are asking you, or what they are asking you? They are asking you the concentration. Concentration beta directly also you can write here, right? So I will directly write the concentration, right? Concentration, we know that concentration is equals to, just okay, I'll tell you what to do next. Okay, now they are asking you number of moles of molarity of NaCl. Molarity of NaCl is number of moles of molarity of not NaCl, they are asking you molarity of Na positive. Now number of moles of Na positive in millimoles is 20, and now put the volume also in the milliliter. Now volume will be 200 plus 300, that is 500, right? Okay, because this is a mixture, so you have to add both the volume, right? Now if you talk about number of molarity of Cl negative, right? Millimoles are 20 plus 60. 20 plus 60 divided by total volume is 500. That is 80 by 500. That is the molarity of Cl negative. If you have to write for CaCl2, molarity of Ca2 positive, that is number of millimoles, because if you are taking volume in millimoles, you will take number of moles also in millimoles. So Ca2 positive is 30 divided by 500, and that will give you the molarity of Ca2 positive. That's how you will calculate the molarity of each of them, right? Okay, understood everybody? Right? Okay. Yes, everybody, is that clear? Now let us talk about the next thing here. That is dilution. Now, dilution is when you add water. Now, not mixing two things, I am adding water, right? So, a solution can be diluted by adding more solvent, or usually it is universal solvent is water to it. In the process of dilution, moles of solute remains constant. For example, you are making, let's say, tea or coffee or whatever you like, right? You have added more sugar into it. Now, what you have to do? You have added more sugar. You will definitely dilute it. You will add water, you will add solvent, or for example, you are making milk. So, what you will do? You will add more milk into it, right? So, for example, you're making tea or coffee, you will add more milk into it, right? Now, when you're adding milk or coffee, whatever you are making, in that case, your sugar is constant, you are not adding solute. So, they are saying that whenever you are in the process of dilution, the moles of solute will remain constant. Solute will not change here. Moles of solute will remain constant. Volume increases and molarity increases. Why volume increases? Volume increases, why molarity decreases? Because this is molarity which is equals to number of moles of solute. This is volume in liter, right? We know that whenever this is constant, this is given to be constant, right? Volume, definitely when you're adding water or milk, whatever you're making, you are increasing the volume. So definitely molarity is going to decrease. So on dilution, the concentration of the solute will decrease here, right? Now, moles before dilution is equals to moles after dilution. This we are talking about the solute, right? Moles of solute, right? This we are talking about the solute, right? Moles before and after dilution will be equal. Before dilution, this molarity is M1, volume is V1. After dilution, molarity is M2, volume is V2. So you can just directly write here M1 V1 is equals to M2 V2. And this is a very, very used formula in your chemistry lab. In the lab, you will use this formula. I don't know how many times you will use this, right? When you have any titration, volumetric analysis, everywhere you will use this formula. M1 V1 is equals to M2 V2. And there is one more formula I'll tell you today only, right? After some time, right? Okay, understood? Now, next is mixing of two solutions. Now, here I am not adding something, I am mixing two solutions, right? So, what you have here, you don't have to go through this. I would directly suggest you to just know what is the formula, right? Okay. Formula directly you should know. There is no use of doing this thing, right? So, guys, simple thing is that when you are writing the formula, two solutions of NaOH, A V1 milliliter and concentration is M1, and V2 milliliter, B is having V2 milliliter and concentration is M2, are mixed, then find the molarity of the resulting solution. So, resulting solution, this is also a very, very important formula, that the resulting solution will have M1 V1 plus M2 V2 divided by V1 plus V2. Okay, divided by V1 plus V2. If you want to know, ma'am, how we got this relation, simple thing is resulting solution will be resulting number of moles divided by resulting volume. Resulting volume is V1 plus V2, right? Resulting number of moles is N1 plus N2, right? Now, what was N1? Number of moles will be equals to molarity into volume. Number of moles of 2 will be equals to molarity into volume. You put it here, and this you will get, right? You put this thing here, right? You will get what? After putting this here, you will get M is equals to M1 V1, the same thing you will get. Okay, I'll just write it here. M is equals to N1 plus N2 plus V1 plus V2, and that's how, wait a minute, we can also see, is equals to N1 plus N2 plus V1 plus V2. V1, V2 is the total volume. You can also write it here, total moles total volume, that is N1 plus N2. N1 plus N2 is this, right? N1 is molarity into volume. N2 is also molarity into volume. Okay, that you will to put there, and you will get the mixing. When you mix two solutions, what you will get here, right? Okay, now let us see the question here, that is, how much H2O should be added such that 200 milliliter of 2 molar solution becomes 0.2? How much H2O should be added? So now we are adding water, right? They are asking you how much this should be added such that 200 milliliter of 2 molar becomes 0.2. Initially it is 200 milliliter. Initially molarity is to water. They are asking you, how much water to be added. So we know that M1V1 is equals to M2V2, right? V2 is nothing but it is V1 plus volume of water. Okay? V2 is nothing but it is volume of water. What is V2? When you have a solution, right, in which you have how much water you are adding, that means you are adding water, that means the volume, final volume V2 is becoming V1 plus V of water, isn't it? V2 is V of V1, that was initially, plus V of water. Now they are saying that such that this much milliliter of 2 molar solution, that means this is initial V1, this is initial molarity, right? So this you will directly write it as initial V1 is 200, this is in milliliters, right? So that means answer also will be in milliliters only. This is in milliliters, molarity is given to be 2 molar, right? So we will just directly write here 2. M2 becomes 0.2. That means M2, this is M2, it will become 0.2. This is M2 and V1 is what? 200. This is V of water, right? Simply you will solve this thing here, 200 plus V of water. This will be 400 divided by 0.2. That will be nothing but it is 10 and it is 200. It will be 2000, right? So it will be equals to 2000. This is 200 plus volume of water. That will become 1800 something milliliter, right? Yes, that will become 1800 milliliter, right? So that is how you are going to solve this. Is that clear? Yes, capital M is molarity. Yes, I am seeing your chat. Dilution law, whether it is live, definitely Harsharan, it is live only, right? Hello Shubhan, hello Shubham, hello Shubhan. Yes, I see your chats in between the intervals, right? When I see your chats, you guys don't type. So that's why I'm like, okay, you're not going to interact with me. That's why I don't see the chats. If you guys start interacting, I would love to see your chats because I love interacting with students. But I see only few students are typing something in the chat box. That, that is very, very depressing for a teacher who is standing here saying that, oh, ma'am, we are sleeping, ma'am, we are so lazy to type, ma'am, right? So if you're ready to interact, I am here to interact, right? I love interacting with the kids. But if you're like, ma'am, we want to like completely focus on the board, only doing questions, no ma'am, gupshup with ma'am, then I have to teach that way, right? Even now, see, I have given one full paragraph. It's still I can't see, chat is not moving only, right? What do you expect from me, huh? What do you expect then? They are not here to listen. And that I know they are not here to listen, Suga. I know when I'll stop teaching, then I think they would be more happy. Don't worry, that time is very near, right? Don't worry, because I think you guys want me to leave this, right? Because the kind of behavior that you are showing, I think I'll have to stop YouTube teaching, right? Free of cost, there is no benefit, right? Even love, no appreciation, nothing. You guys, like, no respect for the teacher you have. right? So there is no benefit, right? What, like, I am not a slave of yours, right? I am standing here and teaching you, right? So if you don't want, if you want to pay lakhs and lakhs of rupees for the same lecture, perfect, good for you, go, right? I'll be there, right? Don't worry about that. Okay. Now, next is calculate the molality of KCL solutions. Now, now let's see the next question here. That is, calculate the molality of KCL solutions prepared by dissolving 7.45 gram of KCl in 500 milliliter of solution. Density of the solution is given to you. But these kind of questions are very, very interesting. Okay. So now what they are saying, calculate the molality. Molality you have to calculate. Now molality we know that is weight of solute by molar mass of solute multiplied by weight of solvent. If it is in grams, then this will be multiplied by 1000. Prepared by dissolving this much of KCl, that means here they have given you W2. In this much of solution, that means volume of solution is given to you, okay? Density is also given to you, density. Now, bacha, do we know that mass is density is equals to mass by volume? Density is equals to mass by volume. Density is equals to mass by volume. Do we know that? That means, can I also write that mass is equals to density multiplied by volume, right? Mass equals to density multiplied by volume. So density is 1.2 and volume is given to be, because see, density is also given in gram per liter. So I can also write gram by milliliter, gram per milliliter. Volume is given in milliliter. That is given to be, this whole I am talking about solution. So I am calculating the mass of the solution. Volume is given to be 500. So you can easily, this is given in milliliters. So you will get the 500 multiplied by 1.2 gram is the mass of solution. You can see W1. That is W1. You will put it here. Now, molality of KCl solution prepared by dissolving this in of a solution, right? Density of the solution. See, in this case, for solvent, nothing is given, right? So by this solution, we can understand that they are talking about water here, right? Okay. Now, even that is not important for you. Molality is equals to KCl. You just have to put the molar mass, because you know the solute, what solute you have. So that will, you know, see, right now you know the W2, that is given to you 7.45. M2 you can calculate for KCl. W1 you know from here, you can put it here, and hence you can easily calculate the value of molality. And this molality you will use in class 12 in the colligative properties. In the colligative properties formula in class 12, right? Without molality, there is no formula, there is no answer that you can actually generate. Even for molarity, there is one formula, right? Okay, that you have to be very, very clear about, right? Do the calculations and you will get your answer here. Now, next is parts per million. That is the number of parts of solute present every 1 million parts of the solution. Now, simple thing, students, let me be very simple, I'll tell you. It is just same as percentage, but here multiply by, instead of 100, you multiply by 10 raised to power 6. That's the only difference that you have here, that you have to multiply this by 10 raised to power 6, right? So ppm, let's say they have given you weight by weight ppm. Can you tell me now what is the answer? Weight of solute by, always weight of solution multiplied by 10 raised to power 6, right? If they have given you weight, volume by volume ppm, can you tell me volume by volume ppm? That is volume of solution by volume of solute by volume of solution multiplied by 10 raised to power 6, right? If they ask you, let's see who is going to answer this. If they ask you weight by volume ppm, then you're going to say weight of solute divided by volume of solution into 10 raised power 6. Then you have, let's say, volume by weight ppm, right? Volume of solute divided by weight of solution multiplied by 10 raised to power 6, right? So that is going to be the correct answer, right? Okay, yes, okay, yes, students, yes, Azad, Vasuki, beta, if it is needed, then why you guys don't even reply in the chat box, right? What do you think? Is it a recorded thing, right? That I can just, or I can get into your brains and know what is happening in your brain? Or you want a teacher who is like, who doesn't even care whether the students are able to understand or not? Or I should like skip this habit of asking again and again whether you're able to understand or not, because you clearly are not habitual of teachers asking you this thing. Is it? I don't think so, right? I don't think so. That why this is so. Last is normality. Now, last concentration term, students, that is normality. Now, it is just as same as molarity. In molarity, you had number of moles of solute divided by volume of solution in liters, right? In this case, instead of number of moles of solute, you will have number of equivalents, or you can also write it as number of gram equivalents. You will ask me, ma'am, what is normality? Normality is, I think this is not clearly visible to you. So I'll just, don't worry, you will get the PDF of this, right? Normality is, I'll write it here. Normality is number of equivalents divided by volume of solution, right, in liters, right, divided by volume of solution in liters. Now what is number of equivalents? That is number of moles multiplied by n factor, right? I don't think so that is very clearly visible to you, so I'll just write it again. For normality, we will understand it more in detail, especially it is needed because I'll tell you, just give me some time, right? Now, this is normality. Normality is number of gram equivalents, divided by volume of solution, and that too in liters, right? What is number of gram equivalents? Number of gram equivalents is number of moles multiplied by n factor. N factor you will study, I think you must have studied about n factor in redox reactions. You will study it more in detail in electrochemistry, but in redox reaction you must like, it should be on your tips, because you're not only going to use n factor here, but also in electrochemistry, right? This is divided by volume of solution. That means we know that this part is nothing, but this is normality is equals to number of moles by this is molarity into n factor. That is the very important formula, right? Very important formula. Now you will ask me, ma'am, what exactly is n factor, ma'am? What is the change? You have molarity, you multiplied by n factor. So what is n factor? It is also called valency factor. N factor is also called valency factor. It is also called valency factor, right? So now let us see what is n factor, what is valency factor. So equivalent weight also we will study, right? For that also we first need to know what is n factor. N factor is for element, right? It is the valency. You can see, for example, I talk about Al. Al loses 3 electrons, so that's why its n factor is 3. You talk about group number 1 elements. Group number 1 elements, they lose 1 electron, that's why valency is 1. Group number 2 elements lose 2 electrons, that's why valency is 2. So this valency is actually not a part of concentration term, it is applied in concentration terms. That's why I'm just giving you a recap of this thing. If you want me to take a lecture on N factor in detail, I'll take up a lecture specially on N factor, because that also you are going to use in your class 12th electrochemistry. So that also should be on your tips, right? I'm just giving you like brush up of this, what is N factor, what is needed. So for iron, it is the charge on the ion. For acid, it is the number of H positive ion released. For example, HCl has N factor 1. H2SO4 has N factor 2 because it releases 2 H positive ions. It is base, it is number of OH negative ions released. For example, for KOH, it is 1. For CaOH twice, it is 2, right? So number of OH negative ion released by one molecule, 1 mole. Salt, it is the positive and negative charge balancing. That means if I say you have NaCl, right? Na positive you have, Cl negative, that means N factor is going to be 1. But if you have AlCl3, in this case we know that you have Al3 positive plus you have 3 Cl negative. That means N factor, positive charge is 3, negative charge is 3. So N factor is going to be 3. Let's say you have Al2SO4 thrice. Can you tell me in this case what is the N factor? You can dissociate it. This will be, you can also use it like, okay, dissociate it. This will be Al3 positive because aluminium always is Al3 positive. SO4, it is 2 negative. So that means here, how many aluminium you are using? 2. How many SO4 you are using? 3. So that means total positive charges 3 into 2, 6. Total negative charges 6. So N factor is going to be 6 here, right? So you can also write it with the same pen. N factor is going to be 6 here. That's how you will tell about the salts, what is the N factor here, right? Now, based on N factor, you also have one more thing, that is equivalent weight is the ratio. What is equivalent weight? That is, first is molecular weight, then there is equivalent weight. So that relation also you will use in your class 12. That is, equivalent weight is equals to molecular weight divided by N factor. N factor, bacha, you have already studied about it. N factor, I have already told you. Now, if you want a detailed lecture on N factor, then you can always let me know. But for that, I want 100% like live watching here. I can't teach with this much crowd, right? Which is not, who is like those students who are not even interested, right? Okay. So I would love to see you guys interacting, right? Love to see you guys determined for what you are dreaming about, right? Not here just daydreaming and not doing anything about it, right? Okay, so if you're genuinely interested, only then write. Otherwise, I don't want to take that lecture of N factor. I'll only take if you guys are genuinely interested in that, right? Okay, I want to give the best to you, but for that, you should also be little bit responsible, right? Now, but based on this, now there is one more thing, that is strength. Strength is also related to molarity. That's why I'm writing this here. Now, what is molarity? Molarity is number of moles of solute divided by volume of solution in liters. Strength is weight of solute divided by volume of solution in liters. That is strength. Now, can I write what is molarity? Now, everyone write what is molarity. Molarity you can write here, molarity is number of moles of solute divided by volume of solution in liters, right? So can I also write it like this? This is W2 by volume in liters. This is W2 by M2 into volume in liters. So can I just write here, this thing is nothing but this is strength, right? If I call strength as S, so can I just write here, this is strength. So molarity is equals to, molarity is equals to, molarity is equals to strength divided by molar mass, okay? Strength divided by molar mass. That is called the relation between molarity and strength, okay? So whenever you will see molarity, moles, units by units also, sometimes they will confuse you in the exam. You will see JEE questions, in good level of questions, these basic things are used, right? So they confuse you. They don't tell you they are asking you strength or molarity, right? If you're not very like, okay, you have not done enough practice, then you might get confused in the exam regarding that. So that's why this thing is very important for you, that if molarity, the moles, in molarity, the units are mole, number of mole per liter, right? But in strength, the units will be, strength of the unit is gram per liter. That is the difference. From this, you will differentiate whether they are asking you, sometimes they will give you, find the concentration in gram per liter, right? That means they are not asking you to find the concentration, find the molarity. They're asking you to find the strength. Sometimes they will ask you to find the concentration in mole per gram, right? Or mole per kilogram, right? If they give you units are mole per kilogram, right? Can you tell me what they are asking you? If they give you find the concentration in mole per kilogram, what they are saying? They are saying molality, right? That means this is unit of molality. Molality. Okay, that you should know, right? This will really, really help you in your exams. Especially this is what they confuse. This is where students are mostly confused. Molarity, usually they don't compare it with strength, right? But with molarity and strength, confusion might happen in the exams, right? Okay. Yes, Suga, Priya, Vasu, JEE, yes ma'am, lecture for redox reactions and N factor. Redox reaction in detail, I'll take it, don't worry, right? But right now, I'll focus on only the core concepts, right, that students are usually weak in, right? Because completing one shot of redox reaction, N factor, then I can only take it for maybe 30 minutes to max, right? But if I take separate lecture of N factor, that will be like, I'll take it in like more detail, like from the basic I'll pick up, so that N factor, anywhere they ask you, you can easily answer. Because I see when JEE advanced question you will start solving, right? In that concentration terms, normality, N factor, you know, some difficult questions will come up, right, regarding the same N factor. For that, you have to polish N factor in a very good way, right? Not only just knowing that this is a very basic thing about N factor. This is not in detail. This is a base of N factor. N factor in reactions, in balancing, so much, it is so much in detail that you should know if you're actually targeting JEE Advanced, right? Okay, for JEE means also you should know, right? But for JEE Advanced, it is necessary. It is necessity that you should know that, right? Okay, everybody. Now, those students who are asking me about the lectures, then students in detail lectures, right? I know that you are like, ma'am, we can't invest so much right now. Then if I ask you one thing, can you invest 3,999 on your future, right? 3,999, right? For 1 year, we are providing you for 12th class and the droppers. This is the Sigma batch where we are providing you the live classes. Like just like now I have taught you concentration terms, right? On YouTube, you know what happens, as I am telling you, I have to again see in this 1.5 hours, right, 88 minutes of lecture, even you know that 20 or 25 minutes are wasted. Why? Because I have to again and again see the students, why they are not studying in this and that. But in the batch, every single student is full dedicated, right? There is no gupshup they are doing, no chit chat they are doing. They are fully focused so that you can also know what are my competitors doing at this point. Full discipline is maintained in the class by the teachers and by the students as well. right? So there are quizzes in the class, right? Because here, we don't have it, it's not our own platform, right? You can't, it's not like completely for educational base. This is the general platform YouTube we have. So in our platform, this is, that is totally dedicated towards the students need, right? So we know that you want quizzes, you want to see that where you are in, like in competition with your mates. So for that, we firstly, every single topic, like I have covered 7-8 topics here, molality, every single topic there will be quizzes. In the end, there will be result that how much marks you got in today's class, right? After the class, you will have DPPs, right? DPPs means based on this one lecture, you will have 10 to 15 questions, right? You'll have to solve that. That is your daily homework. Apart from that, we are providing you Tattva modules, which we firstly we will solve in the class the questions from the Tattva modules. We'll also solve JEE previous year question, and from other competitive exam good level questions we will solve. Then after that, we will also give you some questions for homework. We are not saying like 30-40 questions. We'll give you some important questions for homework that you must do, but for practice, definitely you have to do all the questions, but you will get to know that, okay, these are some very important questions. I have to do these questions at least, right? After that, if you still want more practice, then you can generate your own DPPs also by putting the concept and what is the easy, medium or difficult level you want. And students, if you talk about ma'am mock test, ma'am, are you providing us mock test? Then yes, we will take mock tests every 15 days for the portion that we have covered in those 15 days. Mock test we will take after that, right? After every 2 weeks, right? On Sunday, your mock test will happen, and the report card, the result of that mock test will be provided to you so that you can work on that, right? There will be doubt sessions, there will be Q&A sessions, right? Dedicated to Sigma batch students, so that, for example, you are getting some doubts in chemistry or physics or maths, right? That will be in the closed environment, right? You will have your teachers and only you. When you only want to discuss doubts or you only want to discuss the problems that you are facing right now in your preparation, right? How to act. If you're thinking that, ma'am, I have school in the morning, then the batch timings are according to your school only. You don't need to worry about that. This batch is designed for both the 12th class and the droppers. So you don't need to worry about your school in that, right? So that is a full-fledged thing what you need at this point. And if you're also looking for the test series, then we are providing you 40 part and full syllabus test as well. So that also you can give, right, whenever you have free time, right? So everything that you need, we are providing you. Even if you're thinking that, ma'am, I'm just tired of, ma'am, these laptops. Yes, I'll watch your lectures online, but I want to practice from books, right? So then hard copy of Tattva books are also available. It's totally your choice. You want to go for soft copy or the hard copy, right? That's totally your choice. Now, students, you can just see over here, right? In the description box, there will be, wait a minute, yes. Wait a minute, yes. Sigma JEE batch. Just click on here. This is for 2026 students. Click on here. That is at 3,999 right now. Right, earlier it was 7,999. At this point, it is 3,999. Just go for it, purchase it, and you are not going to regret it. I can guarantee you for that, because the teachers are also very disciplined. There are no cancellation of classes or nothing like that happens in the batch. Right, teachers are even like so much disciplined that you will yourself see that yes, it's just like I'm sitting in the offline class, right? So that same thing, right, you will get here, right? Okay, so that's it for today, students, and then I'll see you in tomorrow's class, in the next class. Harsha, don't worry, we'll start. Yes, don't worry. Okay, then, students, bye-bye, everybody. Bye-bye, take care. See you all in the next class. Bye-bye. You can also let me know in the comment section what you want for the next lecture. Till then, bye-bye, take care.